Welcome, I'm Mr. Anderson, and this is review of 8.1 and 8.2. We're talking about direct variation, inverse variation, and I'll throw some joint variation in there for free, and then we will graph a simple rational function. All right, let's take a look at direct and inverse variation. It says, tell whether x and y show direct variation, inverse variation, or neither. And we have two examples here. Now, if you recall, if it can be written in this form, y equals some constant times our variable x, right? Then we have direct variation between the variables, direct variation. As y increases, x also increases. If it can be written in the form of y equals a over x, thus we have inverse variation. All right, as one increases, the other decreases. Well, let's take a look at these up here. Well, if you notice, this is exactly in our direct variation form. All right, it's just the y's on the other side of the equation. We can just switch that right around. This is y equals 6x. All right, so this is direct variation here. All right, and let's take a look at the next one. All right, so we've got xy on one side of the equation equals 5. All right, so our constant is 5 on the other side of the equation. If we want to get y by itself, we divide both sides of the equation by x. All right, that would cancel out those x's there. We'd have y equals 5 over x, right? Which is how we would write an equation that with two variables that have inverse variation. This is inverse variation between the variables. Inverse variation. All right, let's take a look what we got here. Yep. Okay, inverse, direct and inverse variation. Let's take, excuse me, take a look at this. The variables x and y vary inversely. All right, so they vary inversely. I already know that that I can use the equation y equals a over x. And notice also that if I move the x over to the other side, I'd multiply both sides of the equation by x, and I could also use xy equals a as well if I wanted to. It's the same equation. All right, so the variables x and y vary inversely. Use the given values to write an equation relating x and y. Then find y when x equals 2. All right, so they tell me that x equals 3 and y equals 2. I'm supposed to write an equation relating x and y. All right, well, here's an equation, but what I need is a. I need that specific constant value in order to I have this equation specifically relating this x and y. All right, well, they give me x and y, and I'm just going to use this bottom equation. It looks nice and easy. And I'm going to plug in 3 for x and 2 for y. So I find out that a equals 6. All right, so my equation, I'm going to use the general inverse variation equation, xy equals a. There's one of the general forms. And I know what a equals now, so I can just plug this 6 in for a. All right, so xy equals 6. There is an equation relating x and y. Oh, and then it says find y when x equals 2. Well, let me just plug in 2 for x there. So 2y equals 6, and we divide by 2, get rid of that coefficient. So when x equals 2, y equals 3. All right, there's our equation, and that's what y equals when x equals 2. All right, let's take a look over at this one. Again, it's the same instructions. The variables x and y vary inversely. So I can use either one of these equations to set up the equation relating this specific x and y. And they give me x equals 6 and y equals -2. Let me just use this top one this time. All right, so y, whoops, I'm going to plug in x equals 6 and y equals negative. So -2 equals a. I want to find that specific constant value for this specific equation, over x, which is 6. All right, so to find what a equals, I'm going to multiply each side of the equation by 6. Just apply this side by 6. And I end up with a equals -12. All right, so let me plug that in for a. Pull up one of my general forms here again. I'm using this one this time. Y equals a over x. And I know what a equals now, so I just plug that in. Y equals -12 over x. All right, so there's my equation. And now they want to know, what does y equal when x equals 2? Well, this is going to be really easy. Just plug in 2 for x. Y equals -12 over 2, which equals -12 divided by 2 is -6. All right, so when x equals 2, y equals -6. All right, let's move on. All right, so here we have a chart of values of x and y. All right, we need to determine whether x and y show direct variation, inverse variation, or neither. All right, well, if you recall from our equations, we have if y equals a times x, some constant times x. All right, that's a direct variation. And if y equals a over x, that's inverse. I'm going to switch this around just a little bit here. All right, this equation right up here. If I moved x over to the other side, I would divide both sides by x, and I'd end up with y over x equals a. All right, so that's telling me if I divide y by x, I'm going to end up with some constant. And notice, if we flip this over, I guess you could call this 1 over a. We could say that x over y equals 1 over a, but that's still just some constant. All right, so whether I divide y by x or I divide x by y, I'm going to end up with some sort of constant, and that would be direct variation. All right, so if I'm dividing the two values of x and y, if I'm dividing and end up with some constant, then that is a direct variation. All right, let's move this equation around a little bit. If I'm going to move x over to the other side, I have to multiply both sides by x, and I get xy equals a. All right, so here I notice that if I multiply the values of x and y, I'm going to always end up with that same constant, and that's going to be an inverse variation. All right, let's take a look at these values, these specific values of x and y here. All right, if I multiply x and y together, I end up with 2. 2 times 4 is 8. 3 times 6 is 18. 4 times 8 is 32. All right, I'm ending up with different numbers, but my inverse equation tells me that if I multiply x and y, I'll always end up with the same constant. So this is not an inverse variation. All right, let's back up. Let's try dividing. All right, so if I divide 1 divided by 2, well, that's 1/2 or 0.5. I divide 2 divided by 4, that again is 0.5. 3 divided by 6 is 0.5. And 4 divided by 8 is 0.5. All right, so that already is telling me, I know from my equation here, if I divide, over here if I divide x by y and I end up with the same constant, then that is a direct variation. So I know that this is a direct variation. Notice that if I went the other way around, if I divided y by x and ended up with the same constant, that would show me direct variation as well. Let's go the other way, and 2 divided by 1 is 2, so I'm dividing dividing y by x now, just like in this equation. 4 divided by 2 is 2, 6 divided by 3 is 2, 8 divided by 4 is 2. All right, so no matter if I divided x by y, I ended up with the same constant, and if I divided by y by x, I ended up with the same constant of 2, and it showed me that I have a direct variation. All right, let's take a look at the next one. Let's try multiplying it first. 0.5 divided, or 0.5 times 4, or 1/2 times 4 would be 2. 1 times 2, of course, is 2. 2 times 1 is 2. 4 times 1/2 is 2. All right? I see that I'm multiplying the 2, and I'm ending up with the same constant. All right? So that tells me that I have an inverse variation, just like in my equation down here. When I'm multiplying x and y, like I'm doing here, multiplying x and y, if I'm always ending up with the same constant, then I have an inverse relationship between the two variables. Right? Notice if I divided here, if I divided 0.5 divided by 4, that'd be like 0.125. Oh wait, 0.125. 0.125. 1 divided by 2 is 0.5. 2 divided by 1 is 2. 4 divided by 0.5 would be 8. All right, I'm ending up with a different number there, so it's obviously not a direct variation when I divide x by y. That is not giving me the same constant, so I know it is not direct here. Let's take a look at this one. Let's start off multiplying. Seems to be nice and easy. Let's multiply x and y and see what happens. 2 times 6 is 12. 3 times 7 is 21. Oh, this is not inverse variation, I already know. That's 32 and that's 45. All right, so let's take a look. Well, let's try dividing. 2 divided by 6 is 1/3. 1/3, 0.333. 3 divided by 7. I'm not sure the decimal of that, but it's not 1/3. 4 divided by 8 is 1/2. 5 divided by 9, that's not any of these numbers either. All right, so whether I divided by x divided by y or I multiplied x times y, neither situation gave me a constant, the same constant over and over again. So this is neither. This is not a direct or inverse variation. Okay, so here we have joint variation. And what we have here is a joint variation. We have z equals some constant a times xy. Okay. Use the given values to write an equation relating x, y, and z. Then find z when x equals 2 and y equals 5. Okay, so similarly, like we did with the inverse variation. All right, we start off with our general equation. We need to find the specific constant in this equation, so we plug in the values. Let's see, x is 3, y is 4. We're solving for a, and z is 24. 24. All right, so 24 equals a times 12. All right, and divide each side of the equation by 12 to solve for a. And we have a equals 2. All right, so I'm gonna plug this a value in to my general equation for joint variation. All right, so I end up with an equation z equals 2 times xy. All right, then so that's my equation. All right, it says write an equation relating x, y, and z. I did that here. I related x, y, and z in a specific equation. Now, find z when x equals 2 and y equals 5. So I just plug those in. So z is going to equal x is 2 and y is 5. All right, so when x is 2 and y is 5, z is going to equal 2 times 2 is 4 times 5 is 20. All right, z will equal 20. All right, let's move on here. Okay, we're going to end up graphing a simple rational function here. Here we need to find the vertical and the horizontal asymptotes of the graph of the function. Okay. Well, this right here, this denominator right here, this is going to that is going to tell me where my vertical asymptote is. Vertical asymptote. All right, because when this denominator, when that equals 0, all right, my function's kind of going to blow up. You think about it. Okay, so when x equals 2, this denominator is going to be 0. We can't divide by 0. It's going to be undefined there. But as we get really, really close to 2, this divisor is going to be really, 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 really small. All right, so it's going to, when we divide by a very, very, very small number, this is going to be very, very large. And then we're going to add 1 to it. All right, but this is going to be very, very large. All right, so right at 2, x equals 2. Let's just draw a little graph. This looks awful. Okay, right at 1, 2. Right at x equals 2, right? And typically we'll draw a asymptote with a dotted line. All right, these numbers are going to get very, 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 very large or very, very small. All right, and then the horizontal asymptote. The horizontal asymptote. As x gets very, very large, all right, whether it's negative large or positive large, as it gets very, very large, all right, this is just a constant on top, and we're dividing it by a very, very large number. All right, this is going to get closer and closer to 0. This portion of the equation is going to get closer and closer to 0. So our horizontal asymptote is really going to be determined by this right here. Right, that's going to tell us our horizontal asymptote. All right, so this is going to be 0. As this gets larger and larger and larger and larger, either negative or positive, this right here is going to be the horizontal asymptote. So we got right at 1, y equals 1. All right, our x values, so our x values are getting really, really, really large. All right, but y is going to equal 1. All right, is going to get, well, really, really close to 1. All right, so something on the lines of this right here is what this is going to look like. All right, and as we're really large positive, all right, y again is going to get really, really close to 1. And as x gets closer to 2, right, y gets really, really, really large, right? So this is what the graph is going to look like. This just asked us for the horizontal and vertical asymptotes. All right, so the vertical asymptote here is x equals 2. All right, that's this line right here. All right, now here's our x-axis. Here's our y-axis. So right at x equals 2, all right, that's our vertical asymptote. Okay. And our horizontal asymptote then is right at y equals 1. Y equals 1. All right, let's graph this. Let's graph these type of equations. Okay, so again, all right, same concept. This is going to show our horizontal, or I'm sorry, our vertical asymptote. All right, and then this out here is going to show us our horizontal asymptote. All right, because we just have a constant on top, and as x gets really, really large, this goes to 0. We don't have a number out here. All right, this is like plus 0 out here. All right, so we can see that our vertical asymptote is going to be when this gets to 0. What makes this 0 down here? Well, if we have x equal to a negative 3, right, that will be our vertical asymptote. Our horizontal asymptote is going to be this right here, y equals 0. All right, so let's go right at y equals 0. Okay, we're going to draw a dotted or a dashed horizontal line like that. And as x gets really close to negative 3, that's going to be our horizontal asymptote. Looks like this is a scale of 2. So I will try and draw a dashed line right at, whoops, that was positive 3. Here we go. Right at negative 3. All right, and then we can get more accurate as to what our drawing looks like by plugging in a few values for x and y, or for x. Plug in a few values for x and see what y equals. And we want to plug those in kind of close to this vertical asymptote, right? Because we know as we get really far out here, we're going to get really close to our horizontal asymptote. And we know as we get really far out here, we're going to get really close to our horizontal asymptote. All right. And as we get really close to our vertical asymptote, all right, the graph is going to get really close to our vertical asymptote as well. All right, so we want kind of numbers, x values around here and x values around here. All right, to just make our graph a little bit more accurate. So I'd say this is 2. How about we plug in a 5. There's a negative 5. Let's find out when x equals negative 5. All right, so we're looking for f of negative 5. And let's take also a look at f of negative 1. Negative 1, what is the value of the function right there? All right, so f of negative 5 equals 2 over, plug in negative 5 for x, negative 5 plus 3, which equals 2 over, negative 5 plus 3 is negative 2. This equals negative 1. All right, f of negative 1, we're going to plug in negative 1 for x. Negative 1 plus 3. That's going to be 2 over 2. It's going to be 1. All right, so let me plug in those values here. All right, so this is x comma y. This point right here is our x value was negative 5. Y value is negative 1. Here our x value is negative 1, and our y value is 1. All right, so 1, 2, 3, 4, 5. There's negative 5, comma, negative 1, about right there. Our graph has to go through that point. And our graph also has to go negative 1, comma 1. So right there, graph has to go through right there. Let's try one more point. Let's try f of negative 4. F of negative 4. And let's also try let's try an x value of negative 2. So we'll want to find negative 2. All right, let's find these real quick. We've got 2. We're plugging in negative 4 for x plus 3. All right, that's going to be 2 divided by -1. So that's going to be a -2. That's a point of the x we used there was -4, and the y ends up to be -2. Here we've got, we're plugging in -2 for x. So this is going to be 2 divided by 1, which is going to equal 2. All right, so when we plugged in a -1, we ended up with a y value of 2. All right, so there's 2 more points that we can plug in on this. -4, 1, 2, 3, 4, comma, 2, or -2, right there. And this was a -2, sorry. -2, comma 2, so right here. All right, so I'll try and sketch this in. Out here, we are really close to the horizontal asymptote. We go through these 2 points here, and then we get really close to the vertical asymptote there. All right, so, and then on this side, we get really close to the vertical asymptote, go through those 2 points, and we get really close to the horizontal asymptote. All right, so I hope this tutorial was helpful for you in a review of 8.1 and 8.2, and I'll see you in class.